Respected chairs, my fellow speakers, delegates, all the participants, good morning everyone. I'm Feroz from NOFIMA, Norway. I'll be speaking on recirculating aquaculture systems and mostly on the salmons and trouts. So moving forward, so a nutshell about NOFIMA. It's a Norwegian research institute established in 1970s. Having a headquarters at northern Norway called Tromsø. We have three major divisions: aquaculture, food science, and seafood. And I'm placed at Sundalsora, that is Norway's first research facility established in 1970s, where the genetic improvement program for fish has been initiated, and that was the key point for taking up the Jayanti Rohu project during 1990s through NORAD funding agency. A little bit about the NOFIMA research facilities. So we work mostly on salmonids, and also we work on few more marine species. So regarding the research facilities, we work with wide range of species as well as the stages, starting from broodstock, hatchery technology, and genetic breeding and program, then working on snow and king crab. Then we have a fish welfare laboratory research facilities working on deformities and other welfare issues in fish, then fish nutrition feed technology. And NOFIMA is more known for the land-based production systems, especially on the advanced recirculation systems. Apart from that, we do work more on the cages also for producing salmons and trout. So about the species what we work on, so as I mentioned, it's mostly on the salmonid species, salmon, trout. Then we also work on Arctic char. They are also more similar, but that's purely a freshwater species. Then the marine species, Atlantic cod, halibut, lumpfish, blallandras is a cleaner fish being used for controlling sea lice in salmon. And apart from that, as I mentioned, king crab, snow crab. Then we work a lot on seaweed species, especially on the northern Norway, and then microalgal and many more species. Coming to FKHF, it's kind of similar to MPEDA in Norway. It's working on Norwegian Seafood Council. So if you see the production, Norway produces, global leaders in salmon productions, produce nearly 1.5 million tons of farmed salmon, and they produce 85,000 tons of rainbow trout happening in open sea cages. So we know rainbow trout is being a freshwater, but they are well adapted to the marine system, produced in pure saline seawater systems. And if you see the export value, it goes near about $12 billion in terms of 1.2 lakh crores Indian money. So why I'm talking about RAS? As I told, the aquaculture industry is growing up at larger scale, and due to constraints of water, land, and manpower resources, people are moving towards more into a controlled production systems, especially on the land-based productions, either it's a RAS, a flow-through, or hybrid RAS systems. You can see how the global changes is happening with RAS systems, whether in terms of research or involvement of the private as well as the public agencies. So start with Atlantic salmon, that is the Norwegians' main focus. So salmon is, as we know, they are the migratory species. Their biology is very much unique. You can see here the brooders are maintained in sea cages. And also a few companies like Benchmark Genetics, Movi, they have a pure land-based production of brooders in RAS systems. So the maturation happens either in a sea cages or in a land-based systems with controlled temperature, photoperiod, and everything. But the incubation with egg incubation, because incubation lasts about 100 days with the temperature of about 6 to 8 degrees Celsius, and then it moved to a nursery phase where they produce up to par. It is a freshwater stage. From par, it's go to a smoltification where there were changes in the salinity, photoperiod, temperature happens. So the fish try to adapt to osmoregulations. And those smolt extended to a post-smolt, they grow up to 1 kilogram size. That's typically we called as a juveniles or advanced fingerlings. And those 1 kg fish is being moved to open cages where they grown up to 5 kilogram size, because that is a basic size being harvested for Atlantic salmon. So if you see the image here, how the RAS systems looks like, they have several departments, starting from, as I mentioned, either it's a broodstock facility, incubation facility, smolt, post-smolt, grow out, then all the filtrations and water sludge management systems. It has to be in an intact one facilities. In average, salmon RAS facilities, they have a minimum like 1,000 tons to 10,000 tons facility. That's a single production facilities. And in Norway, like 80% of the post-smolt, that's about 1 kilogram size, being produced in RAS systems. And for the grow out, 30 to 40% being produced in RAS systems. Remaining happens in open cages. So coming to the RAS, as we mentioned, RAS is nothing about, it's different components, equipments being used for recirculating the water, treating the water, and reusing the water. So it has a varied components, starts with culture tanks, mechanical filters, biofilters, then you have a CO2 degassings, ozone filters, UV filters, and oxygenations. And they use all the smart sensors for the pH as well as the alkalinity management. So when we talk about RAS systems, the basic things what we need to understand is the mass balances, like how much fish produce, either CO2 or fecal matters, particles, solids, and how much they consume either alkalinity or oxygens. So everything has to be provided through different components and the pots. So starts with the culture tanks. If you see in general, any commercial farms, they either use a circular or octagonal tanks. Why? Because octagonal is very much of a space efficient, but circular is more into operational efficient and easy way, because circular having a better hydraulics and self-cleaning aspects. If you see about the hydrodynamics, water dynamic systems in a tank system, because many of the RAS gets failed. Why? Because of the poor design. So that is why we give a lot of emphasis on the design of the tanks. And in average, each tank will hold near about 80 to 100 tons. That is the minimal standard being used in Norway. So they need to produce 100 tons of fish in a single tank systems. And the density, they go up to 80 for the salmons, but in terms of rainbow trout, they go almost 120 kg per cubic meter of water. So if you see the net cell about how the tank size, the diameter, and the water volume, the single tank hold about 1,500 cubic and produce nearly 100 tons of fish. And you can see the diameter and depth. And the second component is that once the water comes out of the culture systems, it has to go on to a different filtration systems, either radial flow or settlement tanks. Then it moves to drum filters. Drum filter is being the main filtration components used in RAS systems. And I give a lot of numbers, but I'm not going to repeat it here, but this is for the better understanding of how the system works in a RAS. Once the water comes out of the filtration system, it has to move to the biofilters where all the nitrification, denitrification takes place. So mostly on the nitrification and biofilters, if you see, in present days, many industries are going towards a fixed bed biofilters. Why? Because their efficiency is much, much higher than the moving bed filters. You can see here, you can see almost the tan removal rate is more than 3 to 5 times happening in fixed bed filter. And advantage with fixed bed, it also helps in trapping the particles. But we need to have a self-cleaning system so that whatever quantum of ammonia being produced, it gets eliminated. And since the system is operated under the temperature of 10 to 12, so the startup period for the biofilters goes almost 12 weeks period. And it's purely depend on the salinity, water temperature, and other parameters. And recently we got a project to work towards to find a solutions which is alternative to biofilters. Why? Because biofilters, it's again expensive stuff, and it occupies a lot of space, and it need more maintenance and management. So we are evaluating a study with 3 major RAS producers to see how best we can replace the biofilters by using either electro-oxidation technologies or capacitive deionization technologies. Electro-oxidation technology is purely for the marine systems where we can use the chloride present in the seawater being converted into active chlorine, and that chlorine helps in removing tan, like ammonia, organic matter, and it also having a benefit in disinfection process. But for the freshwater systems, we cannot use electrolyzers because we need to provide them chloride. If there is a less chloride of salinity lesser than 5 ppt, then it takes almost 80% more energy to produce chlorine. So that's why we like having a technology is called capacitive deionization, where the carbon electrodes are being used to remove both positively as well as negatively charged ions. So it's not only helps in removing ammonia like NH4 form, and also it helps in removing like bicarbonate and other things which is really not necessary for producing salmon. Coming to the next stage is the degassing. Degassing, mostly the CO2 is kind of one of the culprit next to ammonia. So CO2 degases in industrial scale is being produced, and you can see here the HRT, the hydraulic retention time, is very much shorter, and it has to remove by pass, like in a single pass, it has to remove up to 70% of the dissolved carbon dioxide. Otherwise, it creates a problem with lowering the pH, and then problem with alkalinity, and it lead to lot of accumulation of kidney stones in salmons and trouts. So we had a project working on nephrocalcinosis in fish. That's kind of a new thing, emerging things we are focusing on. Why? Because of having issues with the pH, alkalinity, then CO2. These three is a deadly combinations that cause a huge kidney stone formation, and it's not like very much lethal at early stages, but if it is not detected, that can create a kind of a huge mortality at later stages. Since like at NOFIMA we have a live facilities, ultrasound as well as the X-ray facilities, you can track individual fish. By tagging them, you can see them how the nephrocalcinosis, the kidney function is happening. So you can do both with the live as well as with the dead fish. And you can see here the CO2, as I mentioned, the CO2 removal, it is kind of a high energy demanding process. So you need to maintain near about 5 to 8 gas or like water and air ratios to have a energy efficient CO2 removal process. So once CO2 has been done, then water has to be disinfected either through ozonation systems or UV systems, and many industries they use both. Why? Because ozone is kind of very deadliest if you don't handle them properly. So you need to have a kind of a UV priming to reduce all the residual ozones present in the water. So the dose purely depend on the purpose what we are using. If it is for the disinfection purpose, you need to go up to kind of 300 to 320 ORP milliwatt. If you are going more than that, then you need to have a UV backup system so that you don't end up with producing more deadliest ozone in the water. And nowadays, nano bubble based ozone generators are being used so that you need not to have this much concentration, about 25 to 30 gram of ozone per kg feed. Because for any of the purpose in terms of salmon RAS, we express them per kg feed. Per kg feed, how much ammonia being produced, per kg feed, how much oxygen is needed, how much carbon dioxide is being produced. So studies with ozone and non-ozone, because ozone not only helps in disinfection, it helps in water clarification, oxidizing the organic matter. And your ozone is having a very short life, shelf life, so it will not cause harm, but we need to have a proper sensors facility so that we control the residual ozone in the water. As mentioned about the UV treatment, it's again necessary if you are using ozone systems, because it takes care of oxidizing the residual ozone, but the concentration, again as I mentioned, it varies for the different species or different pathogens. Apart from UV, peracetic acid as well as hydrogen peroxide being used in RAS systems for the disinfection purpose. Why? Because both of them, they don't cause any harm directly to the biofilter systems, so that your biofilter will not be much affected. Otherwise, as is mentioned, the biofilter startup will take nearly 12 weeks. So it means like once you are using a strong oxidant or a disinfectant, that can collapse a biofilter. The last part is about oxygenation. So in a simple way, fish need nearly 300 to 400 gram of oxygen per kg of feed fed, But in terms of RAS systems, it goes up to 1 kilogram or 800 gram. Why? Because your nitrifications, the biofilters need huge oxygen consumption for oxidizing ammonia to nitrate and then to nitrate. So commercially, oxygen cone or low head oxygenators are used. Why? Because oxygen cone is more in efficiency, but the low head oxygenator more into energy efficiency system. And recently, the Molarier, both Norwegian as well as the American company, they have developed a nanobubble oxygenation systems where you can improve almost 5 to 10 times the oxygenation efficiency for land-based production systems. And apart from this, like NOFIMA, also the many places, they work a lot on the RAS-specific diets. Why? Because the particle accumulation in RAS, that is very much dangerous. Because for removing those particles, we need to invest a lot on the filtration systems. That's why they work specifically with specified binders, specified ingredients, so that they don't cause huge organic matter accumulations. Once you have more organic matter accumulations, that lead to reducing your UV disinfection efficiencies. So off flavor, again, it's a major problem with RAS industries because you are recycling almost 95 to 99% of the water. So larger the operations, you have more of accumulation of geosmin and MIB, especially in the fatty tissues. So that's why we use either kind of electro-oxidation technology or advanced oxidation process where UV and other components helps to oxidize or remove geosmin and MIB. Otherwise, industry had to spend more about 2 weeks of time for the depuration process. By employing this technology, you can reduce maximum to 3 to 4 days. And the last, like why many countries, especially with the RAS systems, how they are advancing. Why? Because they have invested a lot on the automations, machine learnings, and digital twin technologies. In one nutshell, I can say there is a company is having a kind of automatic vaccine systems. Per hour, they are vaccinate nearly 20,000 to 30,000 fish. Not only it vaccinate, it segregate the gender, male and female, and it identify the deformities, as well as it says whether your fish having any kind of internal deformities in terms of nephrocancer and anything. So it like every hour you can screen about 30,000 fish. So coming to the end part of my presentations, they are the global leaders working on RAS industries. The Ocean Loop, they have developed a huge state-of-art shrimp RAS facilities at Germany. Aquapria, they are mostly into a rainbow trout. Others like Aqua Group, Leroy, Salmon, there are Norwegian industries working on rainbow, mostly with Atlantic salmons and also with rainbow trout. My last slide is about, now we are kind of moving towards floating RAS, or it is called like a closed cage systems where salmons and trouts are produced in open seas or offshore systems. One cage can produce nearly 1,000 to 1,200 tons with all kind of automations. We just, a few months before, we got the project with around 20 crore budget. So now we are working with 7 major industries, and we are going to deploy a cage in the open seas by end of this year, and we are planning to work on the water treatment as well as the biosecurity case. Why industry is moving toward this technology? Because like past many years, the sea lice incidence is increasing very sharply. So that is why the technology is being developed, and already it is tested, but we are going for the commercial launch. You can see the sea water and the water inside the cage having no connection. So water is being intaked from almost 30-meter deep, where sea lice is almost nil. So water is took inside the cage. You have a series of filtration systems with mechanical filter, ozone, UV, and then the water goes into the cage systems where you have all the water being recirculated there. Once done, the water comes out. It don't go directly into the sea cages, because they used to keep kind of a well boat, it's a kind of a mothership having all the waste management systems, sludge management systems. All the sludges are kind of utilized or treated, and then water is sent back to the systems. It is kind of a RAS system, a single container of having a 30,000 cubic This is the kind of a recent projects we are running now. This is a 3-year project. Maybe like next year I will present more of the data, how much the production is happening. But this is the target we are keeping now. And these are the companies who is working on. They have a cages starting with 1,000 cubic until 30,000 cubic, or production of 100 tons up to 1,000 tons per cage. With this, I thank the organizing team as well as all the participants here. Thank you so much.